Good afternoon and welcome to today's presentation, Passenger Safety, Train and Bus. Before we begin our presentation today, I would like to take a few moments to go over some housekeeping items. We will be recording this webinar, and this webinar is CLE approved, and we will be asking that you enter a passcode for CLE credit a few times throughout the presentation. In today's webinar, Mr. Berkowitz will discuss slip, trip, misstep, and fall accidents on trains and buses, common safety hazards and easy ways to reduce or eliminate these dangers, and safety topics that are a common concern for the transportation environment. To give you a little background about our presenter, Carl Berkowitz, he is a transportation and traffic engineering expert and has served as a litigation consultant since 1997. He is frequently consulted at the initial stages of a potential litigation for impartial input that can make the crucial difference between success and failure. He can assess the technical merits of a case and advise the client if the action is worth pursuing. He has the background and expertise to explain complex issues in layman terms, suggest strategies, investigate and uncover facts, perform literature reviews and research, prepare reports, and safety evaluations. For those of our attendees who require a code word for tracking purposes, the code word for today is safety. During the presentation, we will take short breaks, and during that time, we will ask that you enter this code into the chat feature for CLE reporting purposes. The chat feature is located to the right of your screen. Please remember that if you are applying for CLE credit, you must log onto your computer as yourself. If you have attempted to log on and received an error, or if you are listening via telephone, please email the passcode both times as requested, and please state the time that you have entered your code in your email. Also, please remember to complete the survey that will appear on your screen at the end of the presentation. As a provider of CLE credits, we are required to have supportive information that you have attended, and in many states the survey is required. CLE certificates will be provided within 24 to 48 hours via email. Mr. Berkowitz welcomes your questions. Please use the chat feature to submit your questions throughout the presentation. We will take intermittent breaks so that Mr. Berkowitz can respond. Thank you all again for attending today, and Carl, the presentation is now turned over to you.
Thank you very much, Ms. Samuel. Today's seminar is going to be quite long, and there's a lot of material to cover. And the topics that we're going to cover are listed on your slide that you see in front of you, and it's quite a bit of material. And I'm not going to cover all of it because a lot of it has been designed, a lot of the PowerPoint slides have been designed for self-study. So where there's a lot of detail, I'm going to leave it. If it's a topic you're interested in, you can come back and take a look at it. You're going to both receive a copy of the link for the video and also a link, I believe, for the PowerPoint. So don't worry about the material. You're going to have two ways of receiving it. This is sort of like in the field of engineering, this is sort of a given. There's a tendency to blame that person that's involved with an injury or an accident with a bus or a train as really being the person that caused the accident in the first place. And this is kind of one-sided, and we're going to talk about the other side today. This ancient Chinese proverb, I hope I haven't misquoted it if somebody in the audience from Chinese heritage, but this is just right on the money. He who trips and falls should not be blamed his foot. And probably the biggest area of personal injuries we have in the United States is slip, trips, and falls. And interesting enough, no matter where you go in engineering, always Da Vinci's name pops up. In fact, Da Vinci led the way in terms of us understanding friction and the role friction plays in slip, trips, and falls way back in 1495. Any of us who walk, no matter what the environment is, we expect that environment to be safe. We expect to be able to walk safely, and we expect to go from point A to point B in a safe manner. But sometimes this doesn't happen, and this is generally the result of geometry errors, holes, uneven surfaces, property characteristics, that's the coefficient of friction, and the speed at which we're walking, the sudden stops or starts, things of that nature. And below there are two diagrams which explain the various aspects of walking, and I'm not going to go into that, and I'll leave it to your own interest. One of the things that always comes to mind is people say, why don't you watch where you're walking? It was right in front of you. But we don't look down when we walk. If we look down when we walk, we would end up falling ourselves. The way we walk is we look ahead. And basically, the general cone of vision is how far ahead we look. We look down, generally speaking, at a 60 to 70 degree angle. We don't look down at a 90 degree angle. And our peripheral vision as shown, and this is our limits to what we can see and how we can respond to what we see. Slip, trips, and falls in the transportation environment, station stops, or what have you, whether a platform, a ramp, a stair, an escalator, a vehicle, all of these environments are a cause of slip, trips, and falls. The slip is primarily one that affects the walking surface that we walk on, the type of person that's involved, a young person, an older person, what activity they're involved in, the various environmental factors, the weather, the temperature, the lighting, all play a role in a slip occurring. A trip requires a different kind of hazard, and that's generally a trip occurs when we have two surfaces that don't meet, and they only need to be a quarter inch, one separated from the other, a quarter of inch high, a quarter of inch low, to result in a slip, or in a trip. Because things that we're not expecting can cause us serious problems. And here's some of the situations where you see surfaces that are greater than 1/4 of an inch. Fall, this is also very important, relates to circumstances, whether the surface is level, on a slope, or are we falling from a height. Important is the age of the person. Is it an adult, a child, a senior citizen, an individual that would fall under the category of American Disabilities Act? Where is the place? Is it a terminal, a platform, a bus stop? Is it on the vehicle? Is it on the bus? Is it on the train? All these play a role in this situation, which will result in a fall. And the general fall factors that we should take into consideration are basically the design of the facility, whether a person loses their balance, is there an issue of maintenance, and these are on the bottom are just a string of things that one needs to keep in mind: the gait, the balance, the stature of the individual, the person's strengths, their vision abilities, and the behavior, how they're performing at the time that the incident occurred. The general fall factors are the interface between the person and the ground, that's the foot and the ground surface, the presence of an obstacle in the pathway, the frictional characteristics of the footwear they're wearing, and the material of the surface that they're walking on, and whether or not the surface is wet or dry, or is it contaminated with some kind of extra ingredient that wouldn't normally be present in the environment. And in terms of the individual, things to keep in mind is their health, their fatigue, what medications are they on, are they under the influence of alcohol, what is the environment like, and what activity are they participating in at the time of the fall. When a person falls, all kinds of falls have catastrophic results. Depending on how far a person falls, really determines the breadth of that kind of injury. If we have a fall from a level surface, this could result in a lower and upper limb fracture, sprains, back or head injuries. There are many situations where people have slipped and fallen backwards, hit their head on the pavement, and the bone in the back of the head that protrudes out acts like a spear and enters into the brain and causes internal brain hemorrhaging and ultimate death. Falls from heights, of course, are more serious because there's the force of falling and the impact of being suddenly stopped. And, of course, that depends on the distance that a person falls and the type of contact surface that they fall onto. This is the formula for friction, and it relates to the surface and the weight that is applied on the surface. I'm not going to get into this in too much detail, but if we know the coefficient of friction of the surface, we can calculate the force, the friction force, that is required in order for an object to move forward. And in terms of minimum values for a coefficient of friction, it is recommended 0.6, and there are various standards out there, and if you're interested, you could take a look at any of them. Mostly they center around 0.5 coefficient of friction. Difficulties in measuring friction are quite concerned. The tendency of people working in the field, especially accident reconstructionists, will pick a friction factor off a table and apply it into a formula and come out with some kind of result, such as the speed at which an accident occurred, the distance that an individual traveled after an accident, things of that nature. But there are a lot of other factors that come into effect. For example, we would expect if the surface is wet that there be a minimum coefficient of friction, but unfortunately there's this concept called stickton, which creates the wet surface creates a bonding with the foot surface or whatever surface is in contact with the surface and creates an artificial coefficient of friction initially until the party begins moving. There are local factors, the types of surfaces, the types of treatments. There is no standard statistical treatment. There are many machines out there that are used to measure friction, and the American Society of Testing Materials International has finally settled on one particular type of machine. A lot of machines that have been used have been proved to be ineffective and not very useful in terms of measuring friction. This is dealing with a train stop or a bus stop. We're going to talk about buses a little bit later, but in general, the concepts for any kind of transit stops are basically the same. The things that we're concerned about is the passenger flow and volume, the walking surface, the external areas, the changes in grade, the stairways, handrails, ramps, entrances, exits, what the floors are covered with, how the escalators and elevators interface with the system. These are all important aspects when we talk about a stop. And to have a good stop, we have to have a good design. And this requires that the pathways are safe and information is provided to help an individual go from point A to point B in a safe manner. There are many standards and codes out there. These are the primary ones. And then also the professional societies have a number of codes. And there are a number of international codes, ISO codes, and industry codes that are not listed here. But in general, most of the codes development interact with each other. I belong to an American National Standards Institute and ASTM, and we interact in terms of sharing codes. And in fact, the codes that the American Disability Act adopted in 1990 comes from those organizations. Excuse me. What we as engineers and everybody, we're concerned about best practices, and this is the way to remove hazards in the first place, by applying best practices. And in fact, most accidents could have been prevented had management understood the dangers that are out there, identified those problems, and made a conscientious effort to eliminate. And below I mentioned two very recent accidents, one on Metro North, and which turned out to be quite catastrophic. Several people died. In order to board a transportation vehicle, one has to safely board, and these are some of the areas that are of particular concern in terms of boarding. We're concerned about accessibility, the warnings when the vehicle's doors are going to close, is the boarding level, is it clear to understand how the boarding takes place, is there conspicuity based upon lighting, is it a continuous path, is there a detectable warning, and everything that happens, is it expected and foreseeable and not unexpected? Is there good information? Is there necessary passive warning devices? Is the surface smooth? Is proper security? Is there proper visibility? So these items that we just went through for boarding, of course, would apply also for exiting or alighting from a transportation vehicle. An area that's received a lot of concern over the last several years after a young lady was hit by a train when she fell through a gap on the Long Island Railroad and went under the platform and got hit by a train that was moving in an opposite direction. I'm happy to report that gap accidents are beginning to disappear, that there's been a concerted effort on part of most transit companies to eliminate both the horizontal and vertical gap. Interestingly enough, if you look at the first picture in the lower left-hand corner, that is the IRT at City Hall Station. And in fact, on the first day of service into the station, which no longer operates, the first accident to occur in 1904 was somebody falling into the gap between the train and the platform on this particular type of train. There are straight platforms and curved platforms. When we deal with curved platforms, there are two different types. There's the convex platform, which is the platform that's curved away from the platform, and then there's a concave platform, which is where the platform is curved in towards the train. One is away from the train, that's the convex, and concave where the train is into the train. And you can see by the four arrows that depending on the position of the train, the spacing between the door and the platform will change based on the position. With the concave, the train ends are closer. In the convex, the center doors are closer. A lot of very interesting studies have been conducted on how to understand the horizontal and vertical gap. And one of the most interesting studies is one that was done in England and in the Netherlands. And what they found is that the gap between the platform and the train isn't just a horizontal gap, it isn't just the vertical gap, but is the addition of the vertical and horizontal gap. Intuitively, we would think it would be the vertical and horizontal gap form a right triangle, and it would be the hypotenuse of that right triangle would be the combination of horizontal and vertical gap. But counterintuitive, those studies that were done in both England and in the Netherlands found that when you look at a gap and want to understand its safety aspects, you have to accumulate the vertical and the horizontal. So, for example, if you have a vertical gap of 2 inches and a horizontal gap of 5 inches, you're based on their work, the gap would be 7 inches, and not 5 inches or not 2 inches. We've read a lot in the papers, and there's been a lot of headlines about people being caught prematurely indoors and being dragged, in some cases, to tragic ending, and in a few cases, the person was able to extricate themselves and avoid a serious injury. Just recently, Metro North had a door that opened not on a platform, but off the platform, and this could cause a serious issue. If the train does not platform and a person steps off, God knows what's going to happen to that individual when they exit the train and there's no platform. So this has happened, and as indicated in that article concerning Metro North. So we have, you have to see a few pictures of people that have been trapped between the train and the platform. In the case of a person that fell between the train and the platform, a community of Good Samaritans got into action, and they pushed the train away from the individual, and the individual was extricated. Unfortunately, in the middle picture, this person was trapped for a long period of time between the extender plates, and this is a plate that fills the gap, and the train, and that person was trapped there for a time. as was this other person in the third photograph. But if you Google this subject area, you'll see many, many interesting videos on the subject and many happy and tragic endings. So what's important is that our passengers need a very safe pathway. The materials that we use for the floors need to be with a high coefficient of friction. If they are ones like some of these man-made stones like terracotta or what have you, these floors need to be treated to increase their coefficient of friction, and specific floor cleaning equipment and scheduling needs to be done to ensure that one maintains a high level of coefficient of friction. Of course, the surfaces that individuals walk on should be free of obstructions. I had an interesting experience in Rio de Janeiro. There was a power failure, and I was walking on the sidewalk, and unbeknownst to me, in the middle of the sidewalk in Rio, they placed benches for pedestrians to sit. And since it was no moon and pitch dark, I found the bench and I made my way to the emergency room in the hospital. The floor area is very important because that's where the footwear and the floor material interact, and we want to make sure that there is no contamination, and that most floors are good and even serve well even when they are wet. But we have to make sure that if they are of some of these man-made materials, that we use some kind of anti-slippery substance to increase the coefficient of friction. There are numerous standards for stairs, and these are the sources for those standards, and I'll leave it to you if you want to pursue them. I will, however, discuss in summary some of those standards. And one of the bottom lines in terms of stair design is consistency, that the riser and the tread should always be consistent from one riser and one tread to another, and that the stairway should be wide enough to accommodate traffic. As you can see, this is sometimes difficult in a subway or a train environment. These are all two-way stairs, but the flow and entering flow and exiting flow prevent these stairs from being used as they were intended for two-way flow. These are the components of a stair that you want to keep in mind. The pitch is the angle of the stairs, the riser we talked about, the tread, and the entire length of the stair is called the run. And the top of the stair or the bottom is a platform area, or there could be an intermediate place, and the riser could be broken into multiple sets of stairs. These are some of the basic materials that stairs are built with, and these are the general requirements that almost all organizations will generally fall into this range of rises and treads and widths and headrooms and deviations and nose projection. The nose projection is the edge of the stair. That's important because we don't want somebody to catch their heel on that, and also tread slope. And of course, handrails are really important, and they should be at the appropriate height. We'll talk about that. A lot of the accidents that occur on stairs can be directly attributed to uneven stairs and stair edges that are not visible and no markings on the nosing, and things of that nature. Handrails are also very important, and these are the sources of standards for handrails. And in general, the handrail should conform to these measurements. And handrail accidents are typically where the handrail doesn't go fully to the end of the stair or the end of the ramp, and the handrails on either side are too far apart, and where there's a situation where one needs to grab both handrails. Ramp issues are generally, the standards are shown on the bottom, and generally the problems with ramps are the steepness of the slope and low coefficients of friction, and many times the ramps are well worn, and by being well worn, the material becomes smooth, thus reducing the coefficient of friction. Even though a material may have a coefficient of friction of whatever it would be, wear and tear will reduce that coefficient of friction. So that has to be considered, and that's why it's important in any surface that's involved in an accident that you take an actual coefficient of friction reading rather than use some number out of a table which may be incorrect. There are hundreds of different kinds of concrete mixes, there are hundreds of different kinds of asphalt mixes, and there are hundreds of different kinds of man-made stone mixes out there in the world today. The ADA generally recommends 1 inch and 20 inches, but most of the standards call for a maximum slope of 1 inch equals 1 inch to 1 foot. These are the sources of elevator standards. Elevator accidents are more common than people will give them credit for, and these are some of the elevator requirements, and a lot of the accidents in general occur because of some kind of failure in the mechanism of the elevator going up and down. The elevators, when they come to a floor, they are generally within almost perfect level with the floor. Sometimes if this gets out of kilter because of an adjustment required, this can be a cause of a problem. The doors having too great a force, and the doors closing too hard and can cause injury on a person that's entering into the elevator. So these are, and some of the other issues that are related to elevators, and I'll leave that to your free time to take a look at further. Typical accidents, as I mentioned, door closed too quickly, door closed with a greater force than acceptable, uneven floors, abrupt starting and stopping, and the lack of handrails sometimes in the elevator. Escalators have standards as well, and these standards can be found in these following sources. The issues involving escalators, and most of the tragic accidents occur with children, children getting their feet caught, and in this case you see an adult, also a young adult, getting their foot caught. These are some of the issues: stopping suddenly, person doesn't hold on, children go on without supervision, fingers in clothing caught, and of course excessive speed. And these are the requirements to have a safe escalator. There are escalators in this world that have variable speeds. There's one in Moscow that's supposed to be the fastest in the world, and for some reason or other, when you get to the bottom, it's like a moving walkway and it slows down somehow. And I think that escalator is the longest escalator in the world. It goes down to a station that was built as a bomb shelter in Moscow in preparation for World War II. The typical accidents, as I just mentioned before, we have entry and exit falls, clothing being caught, abrupt starting and stopping, fingers in the moving escalator. Ms. Samuels, I guess we can take some questions if there are any.
Yes, and before we do the questions, could the attendees please type the passcode into the chat feature? Okay, our first question is, when is the best time to reach out to a transportation expert?
Most lawyers wait until they take their deposition and collect information. The expert has a lot of experience in all aspects of a case, and the best time to bring an expert on board is when the lawyer is retained. The expert can save the lawyer many, many dollars by providing guidance of who should be deposed, not deposed, the questions to be asked, things of that nature. One thinks that hiring an expert later would save money. I think it's on the contrary. The earlier you hire the expert, the lower the cost is for that particular situation.
Okay, and is there any way to eliminate train and bus accidents?
Probably in the real world, probably not, but we could do an awful lot to reduce the number of accidents, and we could also do a lot so when there is an accident that the accident becomes a very minor issue rather than a very severe issue. Accidents, by the term itself, there are always going to be accidents, and the only way to avoid accidents is to be very careful and for the operators to follow their rules, regulations, and guidelines and ensure that all their employees are compliant and properly trained. Any other questions?
Are there national safety rules and regulations that cover urban train and bus operations?
There are national standards of care that have been developed by, like, for example, the American Public Transit Association and the U.S. Department of Transportation, working with all the different properties in the United States. They have come up with what they consider minimum standards. These minimum standards of care are going to become the law soon because the Federal Transit Administration has been given new powers. In urban areas, the Federal Railroad Administration has little impact except for intercity and interurban railroads and maybe even some other types of operations that might be in the urban area. The Federal Transit Administration had some limited powers, and basically the safety of buses and trains in urban areas were left to the goodwill and the independent judgment of each of the properties. This didn't work out nationally too well, so 2 years ago a law was passed. I forget exactly what the acronym stands for, but it's MAP 21, and as part of this law, the federal government has been mandated to develop standards of care for safety of public transportation in urban areas, and that's the trolleys, the streetcars, the subways, and the bus systems in the urban areas. And these are coming along and should be in place in not too distant future. They are slowly but surely developing standards and sending them out for opinion.
Okay, our next question is, when is a fall on a train or bus considered a foreseeable event?
Well, the general standard is an acronym, and it's called SUV. The injury should be sudden, unexpected, and violent. When we're riding a bus or a train, we expect some amount of movement. It's part of the natural operation of a bus or a train. So when that natural movement becomes unnatural and becomes sudden, unexpected, and violent, then that becomes a serious issue and can result in serious injuries and becomes of serious concern.
Okay, those are all the questions we have, so please continue on with the presentation.
Okay, thank you. One of the issues that is a serious concern, and that's crowding. And crowding can come about as a result of breakdowns in service, multiple trains or buses coming into a platform or a station at the same time. And one of the things that an engineer is asked to do is measure the level of crowding. And the method by which we use to measure level of crowding is called level of service. And this level of service starts at A, and the worst case is F. And since these situations occur in such a fast period of time, it's very difficult to get there with your camera and with counting equipment and the number. You probably need dozens of people to count, and it may be even impossible to count. So you need an alternative way to count crowding, and this is the way that I suggest to count, and that is based upon the ability of a person standing on a platform to observe the crowd on the platform. And that is what I call crowd cues, and I've interrelated the concept of crowd cues to the level of service. So instantly, one can determine whether a platform is crowded and at what level it's crowded, and not have to go through an exhaustive, maybe impossible technology to determine actually what is the level of service mathematically. Crowd management is very important. Those considerations that come into crowd management are listed below, and the system needs to be able to adjust itself to crowds, and the success of crowd management is strictly 100% dependent upon the employees of, whether it's subway or a bus or a train or whatever the system is. It depends 100% upon the actions of the staff. And these are the kinds of things they need to take into consideration in planning their crowd management. This is to give you another aspect of level of service, and that's walking, the ability to walk. Level of service A is where you can walk freely without interference. Level of service F is where you can't walk. You're like in a sardine can. And this is a very serious issue and can cause problems. People have been known to be pushed off platforms at this level of service, A, at F and E, for example, because there is no room for a person to maneuver to get out of the way of another person. Basically, they are moving like in a cohort in level service F. So this is very, very important. Queuing is also important. People queue up to wait to get on a train or on a bus, and the ability to move in the queue, you can see at the level of service A, there's full mobility to move in the queue, and as you get to level of service A, F, you're a bunch of parameciums in a water sample with no place to go but hit each other. So you're sort of you're in a situation like bumper queue. One of the things that we want to do is try to calculate level of service. So this is a method, an attempt to be able to calculate the passenger space demand, how much space is needed or not needed for a particular situation. And one thing to keep in mind is that anytime you have an obstruction, whether it's a bench or an information sign or a wall or a pillar, that you have to provide a buffer around that, and what is recommended is 1.2 meters, which is a little bit more than 3 feet as a buffer around. Most people take 3 feet as an acceptable buffer, which is around approximately 0.5 meters. Information is very important. Without information, decisions can't be made, and people can't decide the safe way to do something without having the proper information. This is the type of things that need to be taken into consideration. And when we talk about information needs, one good source of information is the Manual of Uniform Traffic Control Devices, which is basically designed for traffic engineering that can be applied to all sorts of environments in terms of sign design. Also, the American National Standards Institute have sign standards which are nationally accepted standards for safety signs. And these are two very, very good sources of sign placement and information. In-vehicle falls, and when there are serious injuries, it generally can be attributed back to an unsafe operation by the operator, and falls by standing people caused by what we call the jerk rate, and that's the jerk rate is the differentiation of acceleration, which we won't get into unless you're interested in calculus. Basically, it's the feet per second square, and it's a instantaneous sudden acceleration that a vehicle makes, which causes a person to lose balance and to fall. A sway has to do more with the car suspension or in terms of a bus on the suspension system, the shock absorbing system, whatever system they're using. When these systems become inadequate, the vehicle will move in more than one direction. Sway can be in several different directions. Something like a boat. I think they say a boat moves in 5 directions. A vehicle can almost move, if the suspension system is failed, can move in multiple directions as well, like a boat on water. This is a little bit more information on jerk rate and some of the recommendations for jerk rate. We can calculate the jerk rate and the movement of a bus using an accelerometer, which gives us the instantaneous acceleration, which we can translate back into jerk rate. We had a very unfortunate circumstance that's taken on national perspective. In fact, I was interviewed by Time magazine, and the article appears in Time magazine this coming week, and that a person was pushed onto the tracks from the platform. But people fall on platforms for other reasons as well. It could be a medical reason, a disability, or a person in distress, and I hope it's the worst case scenario that somebody wants to end their life and they jump in front of a train. I hope that is not the reason why people end up on the track. These are the things I mentioned. These are some photographs, actual photographs of situations where people are on the track. This last photograph was a woman let go of her stroller, and the platform was sloped towards the track. The stroller fell in front of the train. Thank God the train operator was alert and saw the stroller moving and stopped right in front of the stroller, and nobody was hurt. Thank God. One of the issues that comes to mind in any kind of accident, whether it's the person who is injured or the person who's operating the vehicle, what does it take to identify a situation and then to be able to take action? And this process we call perception-reaction time, and this is sort of a breakdown of an individual involved in an accident. And laboratory studies have shown that this whole process, believe it or not, takes about a second to take place. Now, there are studies that have shown less. The New York City Transit Authority buses, I think they show something like 8/10 of a second, somewhere in that neighborhood, for the perception reaction time. This is how fast the person can respond. This is just repeating what I just talked about. And of course, any failure in any of those steps that I mentioned could result in tragedy, either for the person operating a vehicle or the person that is walking in the environment and interacting in the area where vehicles are present. One always tends to blame somebody for every accident. One that does get a lot of blame, and in some cases they are not to blame, is the operator. And a lot of the studies that have been done of people operating, train drivers or bus operators or trolley drivers or light rail vehicle operators, these are tend to be the types of things that become of concern. And some of the things that can ultimately lead to a bad situation. And one of the things that becomes of concern is there was a movie, a famous Japanese movie called Rashomon, where a stagecoach is robbed, and there are 4 passengers on the stagecoach and a driver, and each one was interviewed as to what they experienced in terms of the robbery, and lo and behold, all 5 individuals had a different recollection as how that situation occurred. Of course, a video makes it very clear. It's indisputable. A written report may be an alternative, but one has to view all the accident reports together, because people don't always see what they've seen. There's a very famous study that was done, I believe it was at either Harvard or MIT, where at a basketball game they had one of the students dress up as a gorilla and run back and forth with the teams during the basketball game. And after the basketball game, they interviewed the audience to find out, in a random basis, how many people observed the gorilla running back and forth. And I think that the results were very low. Less than 50% of the people who were watching the basketball game saw the gorilla running back and forth, because nobody expects a gorilla on the basketball court. You're watching the basketball players running back and forth, dribbling and shooting hoops. So this is a serious concern. And of course, the more and more video cameras that are placed in public transportation, the better we'll understand what is taking place. These are the general human errors that can be applied to operators, and in fact, they could also be applied to passengers as well. Passengers can be subject to some of these same types of errors, and they are. There have been many studies, behavioral studies that have been conducted on the importance of applying attention, and when one does a redundant job and one has many tasks to perform at the same time, maybe reading rules and regulations, special orders while driving the train or operating the bus, having special directives having to read, communicating on a radio while driving, all those kinds of things take away from the attention of the job at hand and can lead to results that we're not really happy to see occur. So this is some additional information about attention control and the importance of having attention. There are many, many studies in this area, and in fact, this is some of this material I'm going to be covering in a chapter I'm writing in a book soon to be coming out on this very subject matter. One always wants to know is how long does it take to stop a train or a bus, or for even an individual to stop and change direction? And this is a very important question, and can be dealt with in various ways. For example, we can determine from event recorders and studies that have been done how long it takes when the emergency brakes are applied, and when they're applied at a specific speed, how long it takes to stop and come to a full stop. And the information is basically applied to this little basic diagram, which we take all the information that we have from event recorders and other sources of information, and we can almost precisely determine the perception. We can almost determine the perception reaction time to some respect, and that's a little bit more difficult from the event recorder because we don't have GPS at the current time, although that is being added to event recorders, particularly on automobiles, and soon to be added on trains and buses. But from all the information out there, we could plug it in and we can get what is the necessary time to stop the vehicle. Perception reaction time, there have been numbers of studies. One study I want to bring to your attention is the U.S. Department of Transportation MIT study, which was of train operators and students, and they found that the perception reaction time averaged out about 1.6 seconds for train operators. And for individual walking speed in general, this is between 3 to 4 feet per second. So if a person's in the middle of a track, for example, or in the middle of a crosswalk, and they're walking at that speed, you could see that they could get out of the way of a vehicle in, let's say they have to get out of the way in 8 feet, it would take less than 2 seconds. So if an individual is pre-warned, they have that opportunity to get out of the way. And if they're not pre-warned, well, the circumstances are unfortunate. This is just a little table to show you if you have 1 second or 2 seconds or 3 seconds and you go at 10 miles an hour, how long it takes you to stop. And conversely, if you go 50 feet, 100 feet, 200 feet, how long it takes you to stop at 10 miles an hour. This is an interesting little table. And this, I have other information for other properties, but unfortunately, they have not permitted me to. This is public information. The other information is not public information. So this is generally the emergency and full service stopping and speed at 10 miles an hour for the New York City subway system. And you can see that the difference between full service stopping and emergency stopping isn't as significant as you think it would be. It's only 10 feet in the case of brake stopping of an empty car, and again it's 10 feet in a maximum loaded car. Light rail vehicles have been found in studies to have twice the emergency braking speed of subway car. Emergency braking is not very common, and when an operator is asked, when did you apply the emergency brake, they say instantly. But we know from our earlier discussion that's impossible because there's a perception reaction time that takes us to understand the situation before we can take an action, and the action in this case is taking an action to apply the emergency brake. So it's the braking distance over time. In addition, we have to add the perception reaction time to that particular situation. And of course, every situation, if it's an expected situation, most situations are expected. It is very rare that an accident is occurred by something that could be unexpected. Something that might be unexpected is a meteor falling from the heavens or a plane falling from the sky. Most every other thing has happened before. Even those things have happened before, but never have I heard of them falling on top of a subway car, but we almost had an auger drill go through a subway car in New York City just recently. So I would have said that was unforeseeable, but I guess that's even foreseeable. The time to stop, of course, is the accumulation of the braking distance and the perception reaction time of the operator operating that particular vehicle. I'd like to talk now a little bit. A lot of material I talked about covered buses as well, but I'd like to talk more specifically on situations that are applicable solely to buses, and these are generally the type of buses. I wasn't around. I didn't take this picture on the bottom. I can't take credit for that. Bus accidents occur in 4 areas, and looking at studies, they're practically evenly divided between boarding, alighting, in motion, and turning. For example, what does a bus driver see and how far away? This is what a bus driver, this is studies that were done. This is a child on a bicycle, and at various speeds, this is what the bus driver sees. And we know what the result will be of a child crossing with a bicycle at 40 miles an hour versus a child operating at 15 miles an hour. A bus is operating at 15 miles an hour. The slower, of course, the better chance there is of avoiding an accident. It's interesting, accidents occur what we call primary collision. That's the initial accident, and then secondary collision. And a lot of the serious injuries occur during that component which we refer to as the secondary collision. That's where the interior, people get thrown around, the vehicle, this is just after the crash. Onboard safety is most important. Passengers who are standing are going to be in trouble if there's a sudden, unexpected, and violent stopping. There's no reason to rapidly leave or stop at a bus stop or at a light or for any other purpose. Enough time should be allowed. Nobody gets punished for operating safely. A few seconds more or less is not going to change anything, and is not going to cause a bus driver or a train operator or anybody else to be reprimanded for taking a few seconds to give a passenger a chance to be seated. And of course, other options or other things that could happen are steering too quickly, losing control, skidding, bad weather and skidding on bad weather, heavy braking, and poor training on the part of the operator. This is the American Disability Act recommendation for a bus stop. I'm not going to get into this. It's basically self-explanatory. And if you have situations that involve bus stops, you can take a look at that. Here's some samples of different kinds of bus treatments. This is in London. You can see that there are different types of approaches that are used. One thing we want to make sure is that the bus stop is set back sufficiently far from the curb, so if a vehicle loses control, they will not interact with the passengers that might be right up on the curb area. Important when stopping at a bus stop, the signal that you're going right, to scan and to position the bus so that the bus lines up parallel to the bus stop, or if it's a curb or whatever, that it operates in parallel, and there aren't big gaps between getting on the bus and getting off the bus and getting onto the bus stop. It's important where bus stop locations are located, and these are some examples of where the best place to locate a bus stop. And this is the best environment for a bus stop, and this is the best layout in terms of where the bus comes up to the bus stop, and the best vehicle layout, bus stop layout for safe vehicle operation. And these are some of the non-appropriate areas for bus stops. I'm not going to get into this at this moment, it's self-explanatory, but this is where a bus stop should not be located. And this is just a summary of the causes of injuries to occupants on buses, and you can see that they're numerous, but they generally come down to failure on the part of somebody not to operate within the rules and regulations of that particular vehicle that's involved in the occupant injuries. Wheelchairs, many of the buses now have wheelchair ramps, and a lot of the buses now are at a lower level. They're what they call low-level buses. So you have this little ramp that goes in, and it's a lot better than in the old days where the bus driver would have to stop, get to the back of the bus or the front of the bus, and lower a special ramp to get the wheelchair or the scooter person onto the bus. And now with these low-floor buses, this becomes a much easier situation, and there are specially designated areas for which these individuals can locate themselves on a public transportation vehicle. When we're dealing with paratransit, of course, there are other issues that come into play, and including the importance of on these small vehicles of strapping either the scooter passenger or the motorized wheelchair passenger or the manual operated wheelchair passenger in place on those vehicles. Sometimes buses are forced to make turns where they can't make turns, which can cause a problem and can cause a problem to occupants. This is a schematic of the curvature that's required for a bus to make a particular turn. If this is not possible, you don't want then to have the bus operating in this environment, because never do we want a bus to have to back up to make a turn. That's not a good thing for a bus to have to do. A lot of accidents occur external to the bus operation, and a lot of them are caused by right turns or left turns. Bus drivers have a blind area, and if a person is crossing in that blind area, there's a danger of them being hit by the bus, the front side of the bus or the rear of the bus. Pedestrians have to be diligent, and so do bus drivers when they are entering a marked pedestrian crossing area, even if it's unmarked pedestrian crossing area. Care has to be taken in terms of right and left turns to avoid hitting crossing pedestrians. Also pulling into bus stops, we also have to have that. We have that same concern, and as I mentioned, it's important to pull in perpendicular because, as you can see, pedestrians have a habit of locating themselves too close to the edge as the bus is pulling in, and actually this woman's coat would probably be roughed by the bus as it pulls into the stop, because the buses like to pull in 3 or 4 inches as close as possible to the curb. And again, pulling away from the bus stop, one also has to worry about pedestrians crossings, and be careful at all times that pedestrians are looked for. You got to look to the left, look to the right, look to the left, look to the right. Can't be too careful when leaving a bus stop. And don't forget there's pedestrians that have gotten off of the bus that are crossing, as well as those who are in the environment who are crossing as well. The best way to avoid a hazard is get to the root cause in the first place, eliminate the causations. A good accident investigation and following through on the results of those investigations is important to prevent future hazards. Inspection practices are very important. They have to be done with due diligence. Design and construction, the best way to avoid a hazard in the first place is to make sure that we design and construct it out of the original design in the first place and construct it with no hazards. This can be accomplished with good written procedures, by doing accident investigations and later tracking those accidents. We can try to make sure that what happened once doesn't happen again, and institute safety programs such as the system safety programs that public transportation organizations have been required to develop and to follow. And we all have a duty of care, both the operators and the pedestrians and passengers, to be careful. And in terms of those who operate transportation, we need to warn of the hazard, properly instruct our people, have constant safety inspections, constantly update designs as new ideas and standards and safety considerations come into play, such as what's happening with airbags and the shrapnel that's been discovered. And as you know, that 25 million vehicles are going to be recalled to have their airbags repaired or replaced. And of course, in the end, effective communications can go a long way to providing a safe environment for pedestrians and passengers. Right on the money.
All right. Yeah, there we go. Could all the attendees please type in the passcode once again? And our first question is, what was the manufacturer of the accepted coefficient of friction machine?
Holly? I'm not exactly sure who makes it. It's easy to find out. You go to the American Society of Testing Materials International website, and there is you probably can even get it on Google. There is a specification that has been recently released as to the appropriate machine that is acceptable to the American Society of Testing Materials. Actually, I find that the thing that we did in physics lab in high school works pretty good, and that's having some basic equipment, a spring, something you pull with a spring that we did in physics class. That comes pretty close to the results that we get from these very, very expensively designed machines. I think the name of the machine is Brubaker, I'm not sure, Brubaker, something like that. But ASTM International has all that information.
Okay, and how should transportation companies recommend employees and or drivers handle accidents that occur on the train or bus while the driver is operating the vehicle?
You mean if an accident occurs, what should they do at that instant in time?
Yes.
They should stop and inform their control and immediately come to the assistance of those people that are injured, or make sure that others who can come sooner or faster. Step one is immediately stop and notify control and go and do whatever one could do to help those who are injured. Many states, people are concerned about helping people, but I think the Good Samaritan laws that are out there basically protect everybody. It's very hard. I was just watching an NCIS show last night, or the night before last, where a corpsman from the Navy went to the aid of somebody in Virginia. And if you were a corpsman from the Air Force or the Army, you become certified as a EMS. If you're a corpsman for the Navy, you're not qualified. And she went to the aid of somebody, and somebody died, and they wanted to put her in jail for that. But I think that might have been wrong. I think the Good Samaritan laws do come into play, and if somebody does everything in due diligence, I think they are protected by the Good Samaritan law.
Okay, and how does a bus owner or maintenance crew determine if tires have impact damage before a blowout?
I'm really not knowledgeable in this area. I don't know very much about tires. That's an area for somebody who specializes in collision accident reconstruction. There are numerous publications that I've read out there that talk about the condition of sidewalls and the thickness of treads. In commercial vehicles, I think the practice still is to retread them, to use the original body of the tire and put a new tread on it to get additional life out of the tire, because the tires are so expensive. But I'm not exactly sure the inspection process. All I know is the car I own, I have a Volvo, and they tell me that if there's damage to the wall or something, that I get some kind of message. I don't know if that's true or not. I haven't tried it. I wouldn't try it anyway.
Okay, and why don't most buses have seatbelts?
This has been a big controversy. In several states, there are intercity buses that have seatbelts on a limited basis. There are school buses in certain states that have seatbelts. Most school bus advocates in the United States are advocating that every child should have a seatbelt. Small bus vehicles have seatbelts. large buses do not have seatbelts, and there are many people that advocate that seatbelts should be on buses, but I think there are only 6 states that are required on school buses at this time. And the reason that the federal government gives that seatbelts are not needed is the design of the school bus is such that the seat and the positioning of the seat and the design of the seat back and the framing of the bus protects the student. But I've seen pictures of school buses overturning. In fact, in an earlier school bus webinar that I did for TASA, I have pictures of a school bus turning over, and those kids were flying all over the place, and they would have avoided injury if they were seat belted in. I hope that answers the question.
Yes, and we have one more question. What standards exist regarding moving from a bus stop before the passengers are seated?
What standard? There are no standards. The bus is designed with an interior mirror which enables the bus driver to see that all the passengers are seated if there are seats for everybody present. There have been a lot of legal cases in this matter, and in most cases, unless the injuries are a result of SUV, they're saying that as long as the bus driver operates the bus safely, that there are no rules that every passenger has to be seated. There are in the training of operators, bus operators, the recommendation that the trainer usually gives the operator in training is that they should make sure that all their passengers are seated if there are seats available for each passenger, and if you have a public address system on the bus, to make an announcement.
Okay, thank you. Those are all the questions that we have, and we're going to continue on with the CLE information. Okay, this webinar is eligible for CLE credit in California, New Jersey, and Pennsylvania. To ensure that you receive your CLE credit, please complete the survey at the end of the presentation. Also, this is a reminder that the CLE certificates will be provided within 24 to 48 hours via email. In addition to being your best source for testifying and consulting experts, TASA also offers e-discovery and document management solutions, free interactive webinars, and research reports on expert witnesses such as the Challenge History Report 2.0, the Professional Sanction Search, and the Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Carl Berkowitz for his time and effort in creating this presentation. If you would like to speak with Mr. Berkowitz, or if you would like to speak with a TASA representative regarding an expert witness or a case that you are working on, please contact TASA at 1-800-523-2319. This is a reminder that we will be sending out a link to you tomorrow with the archive recording. The archive recording will also be posted in the Knowledge Center on TASA's website. If you have any questions or comments, please email Kara Kovalevsky. Thank you all again for attending, and have a great day, everyone.